start our second session with platformer. I downloaded the project from Blackboard, right? That's where we start. I will open it right now in Unity. Okay, waiting for Unity to start. So we have our character. It is animated. There are 2 animations right now. We'll do more next week. This week, what I want to do, I want to focus a little bit more on 2 things. First, we'll add enemy, and we'll make this enemy smart enough not to fall from the platform. We'll use raycasting to detect if there is any more ground that we can step on. So that's one thing. The second thing that I want to do today is going back to coroutines and reminding you how they work. What we'll create with coroutine will create a door that opens and then automatically closes after some delay. So these are 2 goals for today in terms of coding. Then we'll stop recording and we'll do a little bit of administration so we complete the group formation. So you can submit the GDD by Monday, right? So let's see where we are, right? We have our guy walking, jumping, right? We use physics to do those things. I spent with the first group this week, I spent some time searching for assets for the enemy, something that will fit the jungle environment, and we didn't find much. So the collective decision was to use Scary Snowman as our enemy. There is this winter 2D pack. This one. I noticed that some of you are using those assets in your final projects. That's okay. We'll download this and import. Sorry. We'll use this guy. Oh, another thing. Most of those assets are in a different scale than our original assets. So they're about 3 times too small, right? So what I will do, you can either play with the scale and make them the size that you want, or you can play with the pixel per unit ratio. What I will do, I will change this for my sprites. I know that I will be using 2 of them. One is this snowman with horns. The other one is mounted platform. The platform will be used as a door, and the snowman is a snowman, right? That's my enemy. Scary? You see something like that in jungle? Okay, what do we need? We want to use physics with the snowman the same way that we are using physics with our player, right? So we have to add physical components to this game object. 2 things that we need: physics, rigid body, and physics to the collider, right? And again, you can choose the collider that you want. You can go with something simple like a box collider or a capsule. Or you can go with a polygon collider if you want accuracy, right? Right now, if we play our game, let's move this guy a little bit closer so we can see him. Right here it is. Scary, but not moving. Okay, so now it's time to put some life into the snowman. Let's create a script, enemy controller. Make sure that exactly that we are using mono-develop. And let's open the script. Okay. Here we are. Let's make our view a little bit bigger in the fonts. Can you see that? Is it okay? Okay. So a few things that we need to modify from Unity. We don't have to recompile the script every time. Very first thing that comes to my mind when I'm thinking about moving the snowman is how fast it is moving, right? So float speed. Set it to 1. Private, right? Other things that we'll need, not necessarily to access from outside, but to make our code a little bit more concise and not to ask for it each time, is rigid body 2D. Transform, so we have access to all the information about the position, rotation, and so on. And we also need to know how wide and how high is our snowman, because we'll need that information to calculate a few things, right? So width and height. And as usual, we start with setting up the private variables, right? So game object, get component, rigid body 2D to get the rigid body, and transform get width and height. Cannot get it directly from the game object. That depends on the sprite that we are drawing on the screen, right? So first of all, we need to get the sprite render. Again, this is a component, game object, get component, sprite renderer. And from sprite renderer, we can get width and height. Because sprite renderer has information about the image that it is drawing. Specifically, it has bounds of this image. So it has the rectangle and how high and how wide this rectangle is, right? So width will be equal to sprite dot bounds dot extends dot x, and width and height similar, sprite dot bounds dot extends dot y. Okay, we are ready to move. Since we are using physics, fixed update will be our function, not update. We need this synchronization. How are we going to move our guy? We have two options, right? With the player, we've been pushing, we've been applying force, right? Pushing him up, pushing him to the left or right, depending on the direction that we are moving. But there is another option. We can use rigid body, and we can set the velocity for the rigid body directly. And so we can say, move that fast, in that direction. Okay, so to do that, first it would be nice to know what is the direction that we are moving right now, right? So velocity, my current velocity is this. Now I can modify it. Velocity, and I want to modify only the x component of the velocity. And that will be my, I want to move to the right. I assume that I'll be always moving to the right, and in a second you will see why. So I'm using the normal vector that is pointing to the right, and I'm modifying it. I'm multiplying it by speed, right? Now I can simply assign it back to the rigid body. Rigid body dot velocity equals L. Right is the normal vector. Normal meaning what? You remember from math? What is a normalized vector? What is the property of the normalized vector? The length is 1. Right? So it's a unit vector. In this case, it's a unit vector that is pointing to the right. And in the class vector 2 or vector 3, you have the whole set of those unit vectors pointing in different directions, right? So in vector 3, you have one that is pointing forward, up, left, right, and so on, right? You can use them in calculations like that. If you need to calculate, let's say, a speed or velocity, right, using the proper name, velocity of your object in a specific direction, you can take the unit vector and multiply it by the value that you want, right? And then you will get the vector that is long enough for your units. Okay, so let's save this and let's build everything. X, of course. Build all. Okay, so we're building everything, and we want to test and see if our snowman is moving. And it would be moving if our script would be assigned to it, right? I didn't do it in the beginning. Okay, so I assigned the script, the velocity is set, and it is moving, but it is moving to the right and falling into the kill zone. Get out. Okay, so we have the snowman moving, right? Okay, hooray, hooray. Move it to the view so we can see. Hooray, hooray, but it's not smart enough, right? And it's falling from those platforms. Let's go back to the drawing board, in this case to our code, and let's figure out how to make it smart. How our snowman can detect if we are, if there is ground that he can step or slide on. Ideas?
You compare the bound x of the enemy with the bound x of the platform. You know,
But that wouldn't be enough, right? Comparing just positions of the enemy and the platform will not be enough, because platform can be that small or that big, right? And position can be exactly the same, right? So what I would need to have information about the position of the platform, the width, right? And then calculate where I am on the platform. That's one approach. Lots of code to write and lots of computation. Do you remember how we test player and if the player is grounded? What are we using there? We're using line cast, right? So basically what we do, we draw a line downwards and we're checking, is there anything below me, right? Am I stepping on something, right? It returns an object and it's telling you, okay, this is the object that that I detected, right? I'm crossing. We can use exactly the same approach here. We can use line cast, and we can use it basically like a cane, right? Sticking out and a little bit front and checking if there is more ground and I can move a little bit farther. Right? So first we have to calculate where this line starts. This will be vector 2. I will call it line cast position. We'll use a little bit of the vector math here to calculate it. Vector 2 transform dot position, where I am right now. I meaning the enemy. I want to move this point a little bit down to vector 2 transform dot right times width minus vector 2 transform dot up times height. What I'm doing, I'm moving it downwards and to the left. We can draw this line so we can see if it's on the right corner. 5 dot draw line. We will start in the line cast position and we'll draw it down to line cast position as vector 2 dot. Okay, we save this, build it. Right now we don't want to change anything because that's just a debug. But you'll see that there is a line here. And what you see right away is it's in the wrong corner, right? It should be here in the front. So let's make sure that it is in a proper corner. So what we should do, we should change this to plus. Right? And right now we will hit the play button. We have this line sticking out here, right? Moving, 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 and falling. Okay. I said we'll be using line cast, exactly the same values, right? And we'll check if it is grounded, right? Grounded. Physics to be dot line cast basis. Line cast is returning an object. Raycast hit 2D. You can fetch this whole object the same way that we did with the player, right? And you can analyze the information that is there, right? You get access to the object that is detected. You have access to its rigid body, the collider, lots of information. Right now, what I'm really interested in is there anything to step on? Right? So if it's null, if linecast is returning nothing, then it's false, right? Anything returned by linecast means that there is something to step on. That's why I'm converting directly to Boolean.
What if you have another platform below it, at a different altitude? Would it be true or false? Because it doesn't care about the height, right? As long as it hits something.
No, it does, because this is the beginning, this is the end. So what I'm doing, I'm drawing this line that is long to 1.
Yeah.
If you want your enemy to be able to detect something that is below, right? You can make this line longer, right? You can use exactly the same approach, for example, to detect the player in the sight of the enemy, right? You can decide, okay, 3 units from here, right, from my position, if I see the player, I will start shooting or whatever, right? And then you're drawing the line and you're detecting, okay, this is the player. Right now, we won't just detect right in front of us, more or less on the same level, if there is a platform, right? So if it's grounded, we can just move forward, right? No, not a problem. We can just keep moving. But if it's not grounded, then we have to flip. But I don't want to change this whole thing. I told you in the beginning, I'm always moving to the right. I want to keep that code. Instead of, doing some magic here and adding some multiplication to figure out which way I should go, I want to keep this. So what I will do, I will rotate the object. The local coordinates, local right for this object will be still the same, right? I will flip through rotation, not through scale as we did with the player, right? So I will take the current rotation again, with the rotation, you can do it in many different ways. There is a function, rotate, that is basically getting the angle and the axis that you want to rotate around. You can use directly, as I will do here, Euler angles. Right, so I'm taking the rotation. I will modify it, current rotation. And should I, what is the axis that I should use for my rotation? X, Y, or Z?
Z.
Sorry?
Z.
Z?
X, right?
Z would be rotating like that. And what I want to do, I want to do this.
Y.
Right, so I have to rotate around Y.
Oh, yes.
How much?
180.
180. Right, and then transform dot Euler angles equals current rotation. That should make our body smart. No errors. Let's see. Yay. Right, we can make him a little bit faster. Right, and see that it's working on both sides. It's moving. And it doesn't like us. Pushing me. Now, because we are using velocity directly, it will be quite hard, unless I tackle him down, it will be quite hard to push it. Okay, so we have that. Let's do another thing. Let's create a door. I will take platform, I will rotate it. That will be my door. Okay, I can even make the platform for my snowman a little bit bigger so it's not claustrophobic. We'll give the snowman some space to move. Sorry, what I want to do with this platform, I want to turn it into a door, right? So I will jump here, the door will open. The door will open, meaning it will slide down. You let me go through, releasing the snowman at the same time, and then it will close again. Okay, so that's my goal. I need two things. I need to first make this door solid, because if I play right now, I can just pass through the door. Same thing with the snowman. With snowman. I need to make my door solid. Done. I've added the collider. But I also need another collider that will detect that I'm flipping a switch, right? I need a trigger. So I will add another collider that is a trigger. I will edit it so it sticks out this way and not that way. The door can be open only from one side. Okay. And I need to add a proper script door controller. Add this script to our door. Let's change the name of this object, door. Let's edit the script. What we want to be able to set from outside, the script is fairly universal, is the delay between opening and closing. So that will be one thing. Code, close, delay. We'll set it to 2 right now. You can play with this number. Another thing, serialize field. We need to know where we start. So what is the position, Y position of the door when the door is closed? And what is the Y position when the door is open? Right, so again, private float, open, position, and serialize field, private float, close, position. finally, we need a Boolean that will tell me if it's open. We assume that we start with closed position. Okay? What we'll use for the whole thing is the trigger method. So on trigger enter to D. And we'll create two coroutines. One to open the door and the other one to close the door. Right, so first, void on trigger enter to D, collider to the other. Make sure that your spelling is correct. What this function will do, it will simply start the coroutine, and the coroutine will be called open. This coroutine is a function that returns a numerator, and the name has to be the same as the string that is a parameter, right? So open, no parameters. The whole magic will happen here. What we'll do, we'll check if the door is not open. Then it means that we have to flip the switch. Open equals true. We have to start opening the door, actually, right? We have to start action. And that will happen in the loop. This loop will calculate y position. I'll use p as a variable. From p equals to closed position, p more than or equal to open position, p equals p minus. Now, how fast the door is opening, we should also decide based on our experiments in Unity, right? So there should be another variable here, right? Serialized field, float speed. I will set it to 0.1 f. But we'll play with this value. Okay, so this p is really the y component of the position of the door, right? So really what we have to do, we have to get the game object, transform position, and we have to assign a new value, right? So new vector 2. We don't change x, right? So it will be game object transform position x and p. After each change, we want to do yield return, and we have to decide again how much we wait, what is the delay. Wait for a second. I would say let's keep it short, right? Let's test. What should happen here, if everything is correct, we should be able to open this door. Make sure that, oh, we have to assign also the open and close position. The door is right now closed and the y is equal to 10. So that's my closed position. My open position will be something like that. I want to keep it low. I would say -2 is the open position. To make this consistent, what I can do in the start, I can take this code and on start, before the, not here. In a start function here, I can make sure that we are in the closed position, right? That will bring it back wherever we start. It will bring it back to the right position, right? So if I move it like that and hit play button, it should jump, you see, immediately to the closed position. Okay, I'm coming, and the door is moving, right? The snowman is so eager to see me that falls. Hey, I see that I can make my door a little bit more agile, faster. Okay. Save this. So I have the function to open the door. Now I need a similar function to close the door, because what I will do again yield, return, wait for seconds, and I have the delay, right? After this delay, what I want to do, I want to call another coroutine that will close the door, right? So start coroutine close. Be very similar to the first one. I'm quite lazy right now, so I will change the code here. Right? So what I'm doing, I'm checking if the door is open, because if it's not open, it doesn't make sense to call this. Right? Then I will start with open position. I will move back to closed position, adding speed. The rest is the same, and we don't have anything at the end. Right? If it's closed, it's closed. Basically same loop, right? In different direction. Field. New. Hey. So I'm coming. The door opens. The snowman falls, and the door closes, and we have an elevator. Right? We try to get him down. Oh, I forgot about one thing. In the close, we are not changing the flag. Right, this is open, this is closed. At the end, right, when we are done opening, we should set it's open false. That's why it's not opening anymore. Oh, yeah. Poor guy. What we can do to the snowman, if we don't want this poor guy to suffer that much, what we can do, we can go to the rigid body and freeze rotation around Z, right? It won't be falling anymore.
Can you play with the gravity center, the model?
You can. You can do a few other things if you want. The way it seems like our it seems that the door is blocking the snowman. Or maybe it's not the door. Any questions? So you can use the similar methods, right, in terms of ray casting or line casting in 2D. You can detect objects, right? You can detect enemies. You can use it for shooting. If you don't want to animate the bullet, right? Using line cast is cheaper, right? To detect if you can hit the enemy, right? You can use this to make one object to follow another object within certain range, right? So with fairly simple implementation, you can create a sense of intelligence in your game, right? Not really intelligence, but close enough for a simple game like platformer. With coroutines, on the other hand, you can add these animations, you can add delays and stuff like that, right? So it's worth to remember when you're working on your project. So that's it for today in terms of implementation. What we'll do right now, we'll do the administration part, right? So we'll do the team formation. I will assign, well, you will tell me who is in your team. We'll create those groups. I will assign them to the submission folders so you can complete your submission on time. Okay, I will stop the recording right now.